Hey, I'm going to be talking about how to make compounds from cations and anions, which is not that bad. And then the opposite, which is how to recognize them when they're broken apart, which is a little worse. And kind of talk about what to memorize, which is a little different in an online class, and which polyatomic ions to memorize, or how to recognize them. Also, why we memorize them in the first place. So let's get started. So what we're going to do is kind of this exercise, and up here I have a sodium, and a chlorine, sodium and a chloride, excuse me. And I would say if I gave you a bag of sodium atoms and a bag of chloride atoms, not necessarily in the right amounts, and I said, what would you make out of that? You'd say, well, I think the positive and the negative would get together and they would make a salt molecule. And I'd say, great. Now, obviously, here there's leftover sodiums. That's not what I'm getting at. And the reason I'm putting those extra sodiums in there is to make you think a little bit rather than just sort of combining the two things. Right? So we'll see in a second. So the next one down, I got some magnesium plus 2s, and I got some chlorides. And, as just a super side note, I usually write it like by hand as +2 as opposed to 2 plus, completely the same thing. It doesn't matter which way you do it. Okay, so what would happen if these fellows got together? So we'd have magnesium, he's +2. He needs to combine with a pair of chlorides to make a compound. And so the idea is that cations, positive charge, anions, the negative charge, they get together until they reach a balance. They have to cancel each other out. I like to think about it as the positive team and the negative team fight until this is standstill. So if I tell you one is +2, you know that there's got to be a pair of the other ones. So in this next one down, I've got a magnesium and I've got an oxide. He's -2. Magnesium is +2. We'll get to how do I know that in a second, but if they combine, or fight if you want to say it that way, they get to MgO. Now, there's a way of doing this problem that I've seen, which is like you take the number here and you move it down, and you take this number and you move it down. And if you do that, you get answers that look like this, Mg2O2, and then you have to remember to reduce it, and then you reduce it to the right answer. And that's completely fine. I have no problems with doing it if you want to do it that way. The reason I don't like that is because I see all the time people who, it won't matter in this case, but they, instead of moving the numbers like a crisscross, they move them straight down because they don't really understand what they're doing. They just sort of memorized it, and they kind of thought, well, that makes sense. I'll just do that. I move the numbers around. I think that's what I do. It doesn't really work very well. So if you think about it and just kind of visualize what you're doing, the positives and the negatives have to balance out. So there has to be an equal number of them if they have the same charge. And that makes sense. And then you write the formula down. Okay, so a couple more of these. The next one, if I have K plus, potassium plus, and I've got another oxide, so sort of a flip of the earlier situation, looks like I'm going to need a couple of these Ks to balance out my oxide. Now, of course, there's leftovers here, but we're not worrying about that. I just put extras down so you can kind of see what you get. Okay, so far so good. One atom, plus, minus, seems okay. The next one, though, sometimes causes a little trouble because you'll see there's a lump or a polyatomic ion, a family, a group, whatever you want to call it. So I have a CO3 group, and that entire thing that I've circled in green is -2. So he's going to have to combine with a couple Ks to give you potassium carbonate, K2CO3. And so when you think about it, the O2 minus and the CO3 2 minus are really exactly the same thing. It's just that we replaced one atom with CO3. So for now, you don't have to know why those charges are the way they are. I'm just saying if I gave you those charges, hopefully you'd be able to figure it out. And this can get even more complicated if I replace like the K, and I replace it with a sort of complex one, ammonium, this little NH4 group, right? So it's the exact same thing, but now I have to use parentheses. And I say, hey, there's 2 of those NH4 groups. By the way, if you don't see it, what would happen if I didn't put parentheses in? Don't think there's 42 hydrogens. That doesn't seem right. And so sometimes people will put the 2 in the front, which is, you shouldn't do that unless it's a hydrate. And even then, you don't even need to do it. So that doesn't look right. That's not right. Make sure you put that hydrogen in, the parentheses in the right place. Better to put too many parentheses than not enough. If somebody gave me this answer on a test, I would laugh and accept it. It's fine. It's not necessary, but it's completely okay. Okay, so far so good. We're combining things, but now let's go in the opposite direction, right? And so what I got is a whole set of these compounds, and I'm going to say, yeah, you can combine them to make things, but can you go the opposite direction and pull them apart and say, what are they supposed to be? So we start off with this first example, calcium iodide. And you look at it and you go, well, how am I supposed to know what the charges are? I don't know. So what we do is we got to go get some of them. Some atoms are basically friendly. They're constant. They are sort of always going to be the same charge. They're either 0 when they're an element by itself, or they're, in this case, calcium plus 2. So if you notice in this first row, first column, the family is always plus 1. The next family over is plus 2, right? If we jump way over the other side, to the left of the periodic table, group 7, he's always minus 1, minus 2, minus 3, when it's part of a compound, right? So if you see, in this previous example, CO3, that's not what we're talking about. We're talking about when it's a single atom by itself. All of these examples, single atoms by themselves. And so this 1, 2, 3 group, great. 1, 2 group, also great. In an on-ground class, there's different ways of doing this. Now, some instructors will have you memorize this kind of a tan plus 1, plus 2, plus 3 orange. Tan. I don't know what color that is either. Okay, in cadmium, some people leave off cadmium. Some people put in cadmium. Some people say you don't need to memorize the 1, 2, 3. Yeah. The light blue ones, though, clearly you can't memorize. Chromium, in fact, has also plus 6 and plus 7s, plus 6s. You know, many of these have very diverse oxidation states that they can achieve. So there's all sorts of different pluses and minuses on these ones. So you can't memorize those. So the ones you need to memorize, kind of in the second table, plus 1, plus 2, minus 1, minus 2, minus 3, right? You should know those kind of by heart. You know, just like whenever you see them, chlorine by itself, okay, great. So let's go back here, and I'll look at my calcium, and I'll say, okay, I know calcium is plus 2. And I also could look back at my table and say that each iodine is minus 1. So if I said, where did calcium iodide come from? You could say it's from calcium plus 2, iodide, and an iodide, 2 of them. Occasionally, I'll come back to this. Okay, so the next one down, you look at it, FeCl3, iron chloride, iron 3 chloride. I just gave the answer away. So we have iron, and if you look at this chart, we'll flip back up here for a second. I don't know. Iron could be, it says 2 or 3. I don't know. That doesn't help me very much. So I look here and I say, gosh, you know, what is it? So I don't know iron. Let's go on. I do know chlorine. Chlorine likes to make a minus 1 charge, and there's going to be 3 of them. So what does the iron have to be? Question mark. And obviously, if I have 3 negatives, what does it have to be to equal that? Well, it's going to have to be 3. So 3 to 3. So my iron must be, I realize, plus 3. Yeah. So we do the next one down, and sometimes people mess this one up, the iron 2 chloride. or ferrous chloride, they will remember that when chlorine is by itself, isn't that Cl2? Like hydrogen, nitrogen, oxygen, fluorine, bromine, iodide. All those like to double up. And I think, oh, so maybe that's just doubled up in 0. No. It's part of a compound. When it's part of a compound, it's -1. Chlorine by itself, yes, 0 charge. That's not what we're doing. So I've got a chlorine and a chlorine. I know that. I can process of deduction. I think, what does my iron have to be? It's got to be +2. Okay, so the next one down is an example of, I do this and other instructors do, which is, especially on online tests, you put an answer in that can't be Googled. So if I ask you to name something and I put a real compound in, you can look it up and there it is. And you can kind of tell when people are doing that, because sometimes they'll choose names that are not the appropriate name. It's like they're using a dialect or something like that. This is an example of where this compound doesn't exist. So if there was 8, chlorines, what would the iron have to be? Well, obviously it would have to be iron +8, of which that is not actually correct. You can never have a charge that high. But that's a good test question. I could say, well, what is it if it was real? And you look it up and you have to figure that out. Okay, great. Move on. Let's do some more. All we're trying to find is, what is this made of, right? We're trying to be detectives and see, what's it made of. So here, again, not so bad because I have 2 sodiums and an oxygen. I know the sodiums are +1. And how do I know that? Because sodium is right here in my first group. Oxygen is in the -2 group. So those are my my dependable ones. I know they're not going to change on me. They're going to be always the same charge when they're by themselves. So we move on. This next one down, I don't know gold. Is gold 1 or 3? Could be either one. It's not even on that chart that was up there previously. And I know that there's 2 of them. And I know that oxygen is -2. So that's all the stuff that I know. In red, I'm trying to figure out what's that charge. Well, the charge is +1. So each silver must be +1. Because I need my pluses and my minuses to balance. 2 golds to my oxygen. Okay, last couple ones here. And for this one, let's do this. So I have chromium. I got 3 oxygens versus a chromium. And I love these little cartoons. I think they're really helpful to draw. So they're not just like I draw them for beginners. They're useful. I know that each one is -2. And I say, okay, well, what's my chromium? Oh, yeah, he's got to be +6. Because my positives and negatives have to beat. Almost last one. Very similar question. I've got the oxygen team, the negative team, the haters, -6. There's 3 of them. Each one is -2. Where do I get that from? That chart. Right? Go up here, see my chart, oxygen -2. Chromium, I don't know. Could be anything. The light blue ones, don't know. So I have 2 chromiums. And you can say to yourself, well, I got a -6 charge divided into 2 is obviously +3. And so those are my 2 pieces that I'm worried about. Okay, last one is the gold sulfate. And this one's a little weird because the mistake you might make, and I hope you don't, is to think of it as this. And then you'll be like, well, gee, I guess that's +4 or something. And I wouldn't know. Totally wrong. You don't know. What did they do wrong? Well, this brings us to the next point, which is this. There's 3 atoms in here, and that's a tip-off. This is not 4 separate oxygens and a sulfur. It's a special group that's called sulfate, SO4 2-. And that group has its own special charge, and you have to memorize it. And I will do a quick separate lecture on that. I'll push that off to a separate lecture. on how you memorize those. Honestly, a lot of people online are just going to look them up on a table. So here, each gold has to be +1. Okay, so that's going to be kind of an introduction to the polyatomic side of things, and we'll come back to that in the next talk. So good luck and keep on studying.